Okay, so here is a just a quick, I guess, explanation of just some terminology we're going to be using. One is this idea of absolute extrema. And what we're saying in terms of absolute extrema is the actual on an interval or a domain of a function. And a lot of times we limit it. It could be a function that has an unlimited or, domain of all real numbers, but the bottom line is it is the absolute highest and lowest value that the function can take on those on an interval. Okay, so or the domain of a function. So, when you look at these graphs right here, this first one here, obviously this is the high point and this is the low point. And so obviously the terms absolute maximum value minimum. Remember, the value of the function is the y coordinate. Okay. The X is where it occurs. All right. And so we're saying f of C is the absolute minimum here. That is the value of the function. It's occurring at X equals C. Okay. And, just like what, again, as a review, the term extrema means, it's, a plural, for, you know, more than one. Okay, extremum is a minimum, so or extremum is singular. So, extremum can mean a maximum or a minimum, one or the other. Extrema, obviously, we're meaning more than one or both of those. Okay, so there is there's just some basic terminology we're going to be using. We'll see that in these examples coming up. So the extreme value theorem basically says this, that if you have a function that's continuous on a closed interval, okay, you're guaranteed to have both an absolute maximum and an absolute minimum value on that interval, okay? And, I put here a little note, excuse my dog there. He seems to, maybe he sees a squirrel outside, but anyway, careful when the interval is all real numbers because obviously that isn't a closed interval. Okay, so we can't apply the extreme value theorem because the conditions don't hold. We have to be talking about a closed interval and also a continuous function. So once again, we see that idea of continuity being, coming up again. And typically when we, if you remember what I said, it's a lot of times continuity or a function being continuous is a condition for a theorem to hold. Okay, so we have that case right here, and we don't have the extreme value theorem here, and that's where some of these homework problems pop up. And so you have to use your common sense. I can't use the extreme value theorem here. Okay, so I would have to look and you kind of got to maybe zoom in here, but obviously we see that this is the high point. So f of c sub 3 would be the absolute maximum value, which would occur right here. There is no minimum value, obviously, because this function indicates that it just keeps going downward. This graph actually has neither a absolute maximum nor does it have an absolute minimum because it's going to keep going up and going down, and there is no closed interval. So again, that's the condition to use the extreme value theorem. When I get over here, notice this particular one here. I'm just going to use a graph real quick, and then we'll go and come back in the next video and use the calculus to do this. But we have this interval here, and we're going from -2 to 0. Okay, so what we're doing is we're actually only looking at this section of the graph right here from 0, 10, and -2, 24. And notice, there is it's kind of like you got to take off the rest of this function here. And I could mess around with the domain of that here and have that function plot, only over the interval from -2 to 0. But I guess what I'm getting at, if I only look, again, between -2 and 0, which is, this little section right here, the graph, we can see that we have an absolute min and an absolute max and an absolute min, and the absolute minimum value is 10. And the absolute maximum value is that this black point here, which is, the purple coordinates go along with that purple point. We can see it's below that, but about 24.85. Okay. And so this idea of, it occurs at this point. Now, how did I know this was -5/3 over here to run into this calculator? Well, I'm going to go ahead and I'll show you that, how we use the calculus. But basically, what we're saying for the extreme value theorem is that that max or min is going to occur at either the endpoints or any critical numbers that are within that interval. Okay, and we'll do, like I said, a specific example. We can actually start with this one here in the next video. But again, this was just some terminology here of what the extreme value theorem was and also what absolute maxes and mins are. So, all right, we'll see you next video.